Hi there. Question 7. Carboxylic acids can be used in household cleaning products. Name the functional group found in carboxylic acids. I think it's a good idea to learn all the functional groups. The one in carboxylic acid is a carboxyl group. I remember it with a little pun, carboxyl, like the aisle in a supermarket where the car boxes are. If I just write it's actually carb and then oxy and then L, carboxyl, carboxyl. I also have a way of remembering carboxylic acids and carboxylate ions, which I shall just write over here. So we have car, like a car, and then boxy, lick. Oh, that won't fit. Carboxylic and carboxylate. So if I draw a little carboxylic acid, it'll have a carbon chain and it'll have a double bond to an oxygen and one to an OH, and we'll have hydrogens, and however long the chain is. If I go to the data book, why won't it let me? There we are, data book. You can see that they've written down some of the acids: methanoic acid, ethanoic acid, propanoic, butanoic. And methanoic has one carbon. Let me just draw it. So methanoic would be like that. Just the one carbon. Butanoic, that would be 4 carbons. Oh, no, not being very accurate. And in an exam you have to put all the little hydrogens around. So also when you're asked about the ions happen when that hydrogen comes off. I just get rid of that bit. So now it's a little negative ion, and we've also got a hydrogen plus ion, and that's why it's a carboxylic acid, is because it can decompose to give off these little hydrogen pluses. And that carboxylate ion with the hydrogen missing, you remember that with carboxylate. So what's it saying here? Name the functional group found in all carboxylic acids. Carboxyl. Carboxylic acids have a range of physical and chemical properties. Melting points is an example of a physical property. The table gives information about propanoic acid and butanoic acid. Draw the structural formula for butanoic acid. Now, but is going to be the 4 one. And so this will be butanoic acid. And I'll put in the hydrogens. And then explain why butanoic acid has a higher melting point than propanoic acid. Now, you always get asked this question, and what they want to say is that it has stronger intermolecular bonds. You know how you can have bonds inside molecules, like covalent bonds and ionic bonds? You also have bonds between molecules. So let's say we have this little molecule here. And over here we have another one. So let's do it the same direction. Oh, put all these hydrogens around. So there will be bonds between these molecules, especially as they start decomposing into ions with little charges on them. Then there will be strong intermolecular bonds. And that's what they want to say, you to say. They want you to say that there is bonding between the molecules. I'll just show you the Marcus guidelines. And this is my video on how to memorize all of these functional groups. I'll just make that bigger so as you can have a look at it. These are the various functional groups. I recommend writing them all out. And here is the Marcus guidelines. Butanoic acid has stronger forces of attraction between the molecules. So you get 1 mark for saying there are strong forces of attraction and another for saying that it's between the molecules. And I forgot to mention attraction because if it was repulsion it would have turned into a gas. So there are strong intermolecular bonds or strong forces of attraction between the molecules. Go back to the question. That's the end of the question. Thanks for watching. Bye.